5.5, and 5.6. For example 1, we need to identify a pair of angles need to prove these two triangles. So we already know that side AB equals side MN and side AC equals MO. So the angle between these two sides are angle BAC and NMO. So these two angles are congruent. So these are the two angles. AC and angle NMO. Example 2. We need to identify the pair of sides needed to prove these two triangles using the ASA congruence theorem. So we already know that angle BAC equals angle NMO, and that angle BCA equals NOM. So the side between these two angles is AC and MO. So those sides would be needed to prove these two triangles. So Example 3. We need to prove these two triangles by the AAS congruence theorem. So we already know that angle BAC and NMO are congruent, and BCA and angle NOM are congruent. So if we were to identify that side AC and MO are congruent, then we'd be using the ASA congruence theorem. But we're trying to prove these two triangles congruent by the AAS theorem. So we'd need to know either that side AB and MN are congruent, or BC and NO are congruent. Or BC is congruent to NO. Example 4. We need to prove these two triangles congruent. Triangle CDR and RCA. So you can make a table. So first we'll write our given. Which is this. So side AR is congruent to side CD is known, and side AC is congruent to side DR. So if we want to prove these two triangles congruent, we either need to find angles, but we can't do that in this case, so we need to find the third side, and we need to prove that that side is congruent. So that last side is CR, and using the reflexive property, using the reflexive property, we can prove that side CR is congruent to side CR. Now we know that every side of these triangles are congruent, so we can use the SSS congruence theorem to prove that triangles CRD and RCA are congruent. Example 5. We need to prove these two triangles congruent. So it is given that side MA equals side DE, and that side AN is equal to side EG, and that angle A is congruent to angle E. So now, in order to prove that these two triangles are congruent, we need to use the SAS congruence theorem, because this side, this angle, and this side are congruent to these. Example 6. We need to prove that triangle MNP is congruent to triangle ONP. So it is given that angle MNP right here is congruent to ONP, which is right here. And it's also shown that angle MPN right here is congruent to OPN right here. So in order to prove these two triangles congruent, we need to show that side NP is congruent to NP. And we do that using the reflexive property. And once we know this, we can use the ASA angle side angle theorem Example 7. We need to prove that triangle PQR and triangle STR are congruent. So it is given that side PQ is equal to side TS, and it's also given that angle P is equal to angle S. So we need to show that angle PRQ is equal to angle TRS using the vertical angles theorem. When we know this, then we can use the AAS congruence theorem to prove these two triangles are congruent. Example 8. We have to prove that triangle TIA and triangle XIA are congruent. So we have our given, which says that side AT and side AX are congruent, and it says that angle AIT and angle AIX are both right angles. So using the definition of a right angle, we can see that angles AIT and angle AIX are congruent. So now we need to show that side AI equals side AI, and we show that using the reflexive property. And now we have proven that triangle TIA is congruent to triangle XIA using the HL theorem. Example 9. We need to prove that triangles ADB is congruent to triangle CDB. So we have our given, and it says that side BD, or line BD, is a perpendicular bisector to AC. And side AB is congruent to side CB. So, by the definition of perpendicular bisector, angles ADB and CDB are right angles. So these are both right angles. And then by using the definition of a right triangle, a triangle is ADB and CDB. Triangles ADB and CDB are right triangles. So now we know that this side and these angles are congruent to each other. So now we need to show that the side BD is congruent to itself. So using the reflexive property, we need to show that side BD is congruent to side BD. And then knowing that information, we can use the HL theorem to show that these two triangles, triangle ADB, is congruent to triangle CDB. 10. We need to prove that triangle ADB is congruent to triangle CDB. So we have our given, which says that BD is perpendicular bisector to AC, and that angles A and C are congruent. So, by the definition of perpendicular bisector, angles ADB and angle CDB are right angles. Then we know all right angles are congruent. So angle ADB is congruent to angle CDB. And then we need to, so now we know that these are both congruent. And so now we need to prove that this side BD is congruent. So we use the reflexive property to show that. So BD is congruent to BD. And then using the AAS theorem, because we have two angles that are congruent to each other, and then a side, so angle side, and we can prove that triangle ADB is congruent to triangle CDB. So we need to prove that triangle RHJ is congruent to triangle EHJ. So we say it's given that side RH and side HE are congruent, and it's shown that side JH bisects angle RHE. So you can use the definition of an angle bisector to show that angle RHJ is congruent to angle EHJ. So now we know that these two angles are congruent, and we need to show that side HJ is congruent to itself using the reflexive property, which shows HJ is congruent to HJ. And then, using the SAS congruence theorem, we can show that these two triangles are congruent because we know that two sides of the triangle are congruent and one pair of angles are congruent. So triangle RHJ is congruent to triangle EHJ. 12. So it's given that sides RH and HE are congruent to each other, and RJ and EJ are congruent to each other. So we need to show that side HJ is congruent to itself, which we use the reflexive property for. And then since we know that all of these sides are congruent to each other, we're able to prove that triangle RHJ and triangle EHJ are congruent to each other using the SSS congruence theorem. Example 13. So we have two triangles. We can draw them out. So it's triangle XYZ and triangle QRS. So if we know that angle X is congruent to angle Q, and angle Y is congruent to angle R, and that these sides, X, Y, and QR, are congruent to each other, we would use the ASA, so angle side angle theorem, to prove these two triangles congruent. We know that angle Z is congruent to angle S, that XZ is congruent to QS, and that YZ is congruent to SR. So we know there's a side, an angle, and a side. So you could prove these triangles using the SAS congruence theorem. Example 14. So the measure of angle XYZ equals 90. So this would be X, Y, and Z. So this would equal 90. And then ZW, which would be out here somewhere, perpendicular bisects XY. So that would mean this is also a right triangle by the definition of a perpendicular bisector. So now we have to name all the right triangles and the hypotenuse for each one. So we have two triangles here. They both have a right angle. So by the definition of a right triangle, triangle XYZ and triangle WYX are the right triangles. And the hypotenuse is the side opposite from the right angle, and it's also the longest side. So for triangle XYZ right here, the right angle is here, so the hypotenuse would be XZ. And for this triangle, WYX, the right angle is here, so the hypotenuse would be opposite from that. So that's WX. Example 15. So we need to prove that triangle ABC is equal or congruent to triangle CDA. So we set up our table, and it is given that AB and DC are parallel to each other, and that AB and DC are also congruent to each other. So using the alternative interior angle theorem, we can show, because these two are parallel, we know that DCA, this angle here, and CAB are congruent to each other. So DCA and CAB. Then, using the reflexive property, we can show that AC is congruent to itself. So using the reflexive property, AC is congruent to AC. And then using the SAS congruence theorem, because we know this pair of sides is congruent and this pair of angles are congruent and this side is congruent to itself, we know that ABC is congruent to CDA. Example 16. We need to prove that triangle MAD and MBC are congruent to each other. So it's given that M is the midpoint of AB and CD. Using this and the definition of a midpoint, we know that AM and MB are congruent to each other. So AM is congruent to MB. And we also know that CM is congruent to MD using the same definition. CM is congruent to MD. And then using the vertical angles theorem, we know that this angle AMD and this angle CMB are congruent to each other. So that's angle AMD is congruent to angle CMB. And then using the SAS congruence theorem, we can prove triangles MAD and MBC are congruent to each other. Example 17. We need to prove that this triangle BXA and this triangle CYA are congruent to each other. So it is given that AB is congruent to AC and that these three angles right here, 1, 2, and 3, are all congruent to each other. So now, because these two sides, so if you see triangle BAC, side BA and CA are congruent to each other, or AB and AC. So this is an isosceles triangle. So by the definition of isosceles triangle, triangle BAC is an isosceles triangle. And then using the base angles theorem, we can see that these two angles right here are congruent to each other. Angle YCA or ACY and angle ABX are congruent to each other. So, well, ABX is congruent to angle ACY. And then, since we know these pairs of angles are congruent to each other, and this pair of sides are congruent to each other, we can use the ASA congruence theorem to prove that these triangles, BXA and triangle CYA, are congruent to each other.